hear me from the back. Good morning, everyone, and congratulations to everyone that's made it here by 9 o'clock this morning. We sort of had a little fear that there'd be Vidar and myself for this talk, but congratulations, everyone. This is a session entitled Campus Networking, where we have a range of campus-related services and really end-user topics. We start with Vidar Tinsen from Norway, from Uninet in Norway. Vidar is an engineer with Uninet and it has been involved with this GigaCampus project, which brings the campus network closer to the national network. And one of the things that Vidar has been involved has produced is a public domain network management package that he'll be talking about in this talk. So, Vidar, okay, thank you.
Can you hear me, or is it working? Okay. Okay, thank you. It's a pleasure to be here. I can use that instead. Hello? Yeah, okay. It's a pleasure to be here. As Michael said, I'm with Uninet. I've been with Uninet for the past 3 years. And now I'm working most of my time with this GigaCampus initiative, which is the topic of my talk. Prior to that, I've been with a major technical or the major technical university in Norway, NTNU in Trondheim. So I've been working with campus networks earlier for a period of 10 years or so, which an experience which comes in handy in this project. I was the network manager at NTNU for 4 years. Okay, so in case you didn't know, Norway is up north. It's a long country, and actually if you rotate Norway around the southernmost point, the northernmost point gets to Rome. If we include Spitsbergen in this, we actually get way down in Africa. So why am I telling you this? It's a challenging country to be an NREN in. It's a lot of mountains and fjords. So we have a lot of challenges on the national network. There are many, in the major cities we have the big universities, but there are university colleges spread around the whole country, in every corner of the country. So just one slide on the national network or the research network that Uninet and we are running. We have, to be frank, we feel that we have good capacity in the network. We don't have any bottlenecks here, thanks to a very good agreement that we have had for the last couple of years with one of the main carriers in Norway, an IRU agreement giving us a very nice prices on our transmission. So we have typically in the core of the network 2.5 gigabit links. We have 1 gigabits to other places. And we'll move to 10 gigabit when that will be necessary. So the philosophy of the national NREN, as with other NRENs, I suppose, is we shall always have enough capacity. So we have somewhat 40 universities, we have more than 200 customers and 250,000 users, and we operate this network from our headquarters in Trondheim. So what we're seeing, and I think many of you are also seeing this, that now actually things have turned upside down. The weakest link is actually moved out of the NREN, it's in the campus networks. And when I say weakest link, I don't only think about the capacity, it's other things, aspects going on in the campus networks that needs to be addressed, like security issues, like wireless, which is network, of course, and operational issues. So this is really the background for our initiative that we started this year. So we've given it the name GigaCampus. It has government funding. We're running the program. It's going to be for 4 years, so we just started. But I have to say we had a predecessor, a similar sort of program with a smaller scale. So this is a good advantage to us. We have a long tradition in Norway with good cooperation with, from UNINET to the different universities and university colleges, which is a great benefit as we go about in this initiative. So as we developed this program, we put up a mission statement stating that we would like to provide and coordinate top international level campus IT infrastructures that will promote innovation, cooperation, and productive research and education. So this is a glorious vision. I'll get down to the dirty details as I go along in my presentation, okay? So this figure is a bit confusing, I think. A lot of arrows and boxes going all the way. The idea is just that we have central funding and we get more for the money, so to speak, the way we organize this program. The idea being that there are a lot of projects going on at the universities. They have their own initiatives for different sort of things. For example, implementing tools and stuff. And so if these projects are good, we tell them, hey, this is a good idea. This tool you're developing, could this be useful to others? Could this be useful to the whole Norwegian university community, or even the whole open source community? So we support those projects, and we have them to make their tools more general, and we want to put them in use, and we are doing this in the whole country. And we're also collaborating, I'll get back to this, on numerous projects with the universities in terms of fiber projects, doing investment in equipment and so forth. So as we were discussing what we should focus on in our initiative, we ended up with 7 areas of focus, which are listed on this this slide. I'll go through each area of focus through my presentation. I'll just briefly mention them now. So we address the physical infrastructure, starting at the bottom of the OC layer, then networking, of course, wireless or mobility, person-to-person communication, being IP telephony and multimedia communication, security, of course, service management, and finally end-to-end quality. Okay, another important aspect before I go into the different areas of focus, and this we started last year, and it's really working, and I'm very excited about this. We've named it UNINET Engineering Task Force. What it is a set of working groups in each area of focus. And what we do here is we gather the best we have in Norway of the engineers at the various universities. We get them to meetings that we organize, and we have discussions, much like this conference, and get all the people together and get them talking and discussing what are the issues, what are the challenging that we see as of today. Important in this also is that we have UNINET have, of course, and some of the universities have people participating in international working groups like the Tirana Task Forces and IETF and so forth. And this is also, of course, very stimulating to the people in the Norwegian working groups getting this feedback from the international community. So, and we try to make this participation in these working groups as open as possible. We want everyone to participate, or many people to participate in discussions. We also, and this is important, we try to produce something actually. So what we try to derive in each area of focus is discussing our best practices and trying to, and actually writing down best practice type of documents, and also more practical how-to documents. It's no big, it probably comes as no surprise, but the case is, I mean, we're doing pretty much the same thing on all the different campuses around Norway. We're running similar switches and routers and wireless equipment and so forth, and we're configuring all this equipment. And we're all sitting at our different sites and doing the same thing. If we can get these people together, write some common how-tos, we can help each other. another important aspect of this is that the level of skill, oops, the level of skill, okay, I have to turn that up. That's good timing. The level of skill will vary, of course, some people will benefit more from this than others. Another important thing we're doing in the GigaCampus initiative is, and we've been doing this for a while now, and we just finished a major call for tender on network equipment, campus network equipment being routers, switches, and wireless, and so forth. So what we've done here, again, we've gathered the best people we have at the different universities and ourselves in the process, in the call for tender process. And it's been really exciting to be part of that work. And as we went through the last phases of negotiations with the vendors, I've personally never seen the vendors sweat that much before. We had a pressure on the vendors that we haven't seen before when the whole Norwegian university community is behind. And we've also seen prices that we've never seen before. So this is a very, of course, one of the proofs of that this GigaCampus initiative is actually working. Another important aspect is we save the overall time spent on call for tender processes, which are very time-demanding processes, is of course saved when we're doing this once for everybody instead of everybody's doing this by themselves. So besides network equipment, we've done similar things for telephony. We're currently in the final stages of a DSL contract, which will be for all the students and faculty of all universities in Norway. We are addressing PCs and servers and application software as well. So, but we don't only want to sit, around the meeting table and making contracts and so forth. We also want to get our hands dirty, and this is also another important part of this program. We want to tour the country. We are touring the country. We travel to each of the different campus networks, and in this work, we also have with us skilled people from the major universities. So, and GigaCampus is a lot about collaboration, and it's a lot about teaching and learning from each other, okay? So we talk with the local IT staff at the various universities and university colleges and discuss network design and implementation and so forth. We look at physical infrastructure. We look at all the areas of focus that we have in this program. And we actually help them in the process of implementing new solutions. So to walk through the 7 areas that we've focused on, I'll start with this one. And I guess you've all seen something like this maybe at your own campus. I definitely have, I have to admit. It should not look like this, of course, but it often does. So we feel strongly that we need to address the physical infrastructure, make the physical infrastructure more professional. A lot of the outage we see in Norway, at least, in the network today is due to problems related to the physical infrastructure. And, of course, we need to address, we have old cabling in buildings. Category 3 doesn't work very well with fast Ethernet or gigabit Ethernet. Multi-mode, not a very big issue today, but it will be when we address 10 gigabit, which we are starting to, of course, and when we address lambdas and so forth. So there needs to be a shift to single-mode fibers in many places. And when we're doing new fiber projects today within the campuses, we use single-mode. Power and grounding, also a big issue. We see on many campuses poor routines regarding UPS, no diesel power generators for the main equipment, which there ideally should be. We look at cooling and ventilation, fire detection, and physical security. And very important, we work with in the major metropolitan area, the major cities. We've done many projects already in terms of putting fiber in the ground, putting fiber between the different campuses in the cities, so that we own, or the universities own, their own fiber infrastructure. So we've done projects in Tromsø, Oslo, Trondheim. We're currently working in Bergen with this with the fiber projects. Okay, networking is of course a part of our initiative. What we need to do here is really annually, every year, year by year, we need to invest in the campus network. It's not, we'll never be finished, okay? So this is how we go about. Typically, older core equipment is moved to the perimeter of the network, and we install new core equipment. And we also have the advantage of, when we coordinate this work, we have several advantages. We can exchange, if it's a good idea, equipment between universities. And important also, we can have common spare equipment off the shelf. So if something happens, usually this is at each university when it comes to like edge switches. But when it's core equipment, really expensive equipment, we have a national extra spare equipment for use for the different sites. So in the campus network, of course, we need to add, we intend to implement multicast. It is implemented many places, but not everywhere, okay? So we have to look at end-to-end multicast. We are doing that. And IPv6. IPv6 we've been running in the national network for quite a few years now, but we see that it's not really addressed on that many university networks. So we want to guide them in the process of implementing end-to-end also IPv6 on every campus around. And we're looking at lambdas, so also in this program. Okay, so mobility, just a few words on that. Wireless networks, we're doing a lot there. Of course, many universities have a wireless networks already. What we've done actually this winter, we had two very successful, I think, workshops addressing key practical challenges with building wireless network. Okay, so what we did is there was a university college on the west coast of Norway which really didn't have much wireless, okay? So we arranged a workshop first with radio planning, and we got all the people together that had experience with this and all the people that didn't have any experience and wanted to learn, got them together with different equipment for measuring and stuff, and we went around physically in the buildings at this site and planned the wireless network. Then a couple of months later, we did the actual implementation of the base stations, addressed challenges regarding configuration and security issues, 801.x, and of course, we implemented EduRoam in this network. So what we're seeing now is that more and more universities in Norway are implementing EduRoam, so this is going forward. Mobility, I think mobility will be more and more important as we go along. What we see today is the use of the wireless network, mostly laptops. Mobility is not so, at least I feel this, not so important today, but it will be definitely in the future. We will see more lightweight devices, PDAs, and wireless VLAN phones and so forth. And then we really need to address layer 2 and layer 3 mobility. So we have some challenges there. Okay. This fourth area of focus, person-to-person communication. What we have here, we have today, without an exception, we have the traditional PBXs at the various universities. But there will be, at some point in time, we believe, a shift to IP telephony, voice over IP. So what we're doing here is really a sort of pre-study, getting experience with SIP, playing around with SIP, and trying to address a SIP architecture that will scale for our country. And of course, a key component on this needs to be a good, transparent communication between the old world and the new world. So we're doing a lot of pilots here. We have a couple of pilots out and on different universities this year, so I'm getting experience with this sort of technology. Security will never go away. Security is important, and The number of security incidents, as you all know, it's growing exponentially. We have a lot of challenges when it comes to security. What we see here is that it varies how good the various universities deal with security issues. So again, training is an important aspect of our initiative. We had this spring a course for 5 university colleges where we actually gave them training in how to establish their own incident response teams. And on this one, we have to thank TFC Certs Transits a lot for their material that they were willing to share with us so we can use in our courses. We're going to have more courses similar to this in the future. We also address security policy. The case here too, very few, if any, actually have a implemented security policy. And here too, we feel it's important that they do this themselves, that this is a process that they feel their local ownership to. But still, it's a similar thing going on every site. So we want to guide them in this process as well. So the 6th area, which is my favorite, you'll understand in a couple of slides, it's service management. In the working groups here, we have really interesting discussions. We're discussing how we go about in operating our campus networks. Okay, what routines do we have? How do we deal with incident management, help desk systems, and so forth? How do we do change in our network? And what monitoring system are we using to do a good proactive operation of our campus networks? So, and we're also actually, as I mentioned earlier, we are supporting good projects at various universities, implementing tools that could be useful for the whole community. Another thing we're doing, which is really to the point and we're currently shipping 10 what we call toolboxes, which are basically servers that we install at UNINET and we ship out to the various campus networks. The toolboxes will have an increasing set of tools on them, and I'll go through some of these tools in the next slides, okay? So the idea being we give them good tools, and we also give them training to use these tools. We see that many people aren't using actually almost no tools at all when it comes to network monitoring at the campus network. So there is a lot of work and a lot of benefits that can be taken from, I hope at least, from our initiative. So just to quote Serenata, the report, and we totally agree with this, we are convinced that most campuses do not take their task of measuring and understanding the traffic flows sufficiently seriously. So there's a lot of challenges in this area. So I'll mention this one, and actually, this is, as Michael told us in the beginning, I've been working with this system myself. I'm the founder of this solution, so I might get a bit eager when I talk about this. I could talk about this for 3 hours, but I have 2 slides. Anyway, it's open source. It's an URL there. You can have a look at it. It's a network management system that we've developed at NTNU and now UNINET, and this is one of the tools that's going to be on the GigaCampus toolbox. So just one more slide on this one. I think the key strength of our solution here, we use SNMP, of course, to discover the network. So what we do in NAV is that we are able to auto-detect the network topology on layer 3, on layer 2, per VLAN as well, collecting ARPCAM data and CTP data if it's available. So, and this gives us a model of the network in a Postgres database. We utilize this model in a numerous set of front-end web tools where we can draw the network map, we can give reports and so forth, and we have statistics, of course. Also important and very popular is the machine tracker, the ability to track where a machine is at a given time. Where is the machine in the network currently? Where has it been for the last month or so? Okay, so we're able to track the machine down to the switch port, or if we have the data all the way to the actual physical room that the machine is in, okay? Layer 2 trace route, also a neat tool here. We can trace a machine from, if there is a problem, connectivity problem or something, between two machines, we can track the machine from machine A to machine B on layer 2, so we get the set of switches and routers that are involved in this route. Another tool that we will include, or are including on the toolbox, is Stager, also developed at Uninet, and we've been developing this since 2002. Some of you may have heard the talk of Arne Östlebø. He has had several talks here on the conference, and he is one of the main people behind this solution. So Stager started out as a net flow analysis tool, and it still is. And it's a very good one, I think. But it's actually developed into a more generic tool that are able to store, aggregate, and give a presentation of various network statistics. So we do round trip and packet loss gathering in this system, and we have also a generic SNMP data gathering. So I think NetFlow really complements the previous tool, and this gives the university and university college people some good tools to work with. So this is just a screenshot on Stager showing the AS matrix of the traffic on the national network. Another example, this one showing the traffic between Oslo and Trondheim on a day in April this year. We see the different types of traffic, the red being the unknown. I wonder what that could be. So finally, the seventh area of focus, also a very exciting area, is the end-to-end quality. What we're doing here is sort of similar to the previous area. We're also shipping out machines. We're installing them at Uninet and shipping them out to the different campuses around Norway. Currently, we have 15, we call them measuring beacons, placed at the various sites around Norway. We also have 2 of them way up north at Spitsbergen. So what we're doing here is, while the toolboxes address primarily the challenges of running the campus networks, the measuring beacons address the challenge or look at the traffic out of the campuses and between the campuses. Okay, so one of the tools we're running is the IPv6 multicast beacon, which is really nice and gives us, I should say that the measuring beacons, many of them at least, have GPS antennas, so we have a really precise clock, which gives us the possibility to measure not only two-way round trips, but one-way round trips in the network, which is shown in this multicast beacon tool. It gives us one-way traffic loss, delay, and jitter. And we're also running more tools on the multicast beacons, and as we go along in this program, we will add more tools. Round trip data we have on them. We're using NDT or network diagnostic tool from Internet2 running on them, which gives the end user the ability to measure his bandwidth to a given measuring beacons. We'd really like to install, and we probably will install SurfNet Detective on all these measuring tools, giving the end users the ability to measure lots of things to the measuring beacons. Okay, so how am I doing on time? Okay, yeah, I'm almost finished. Okay, so just a couple of slides more. I should say that we participate in the GEON2 JRA1 effort and the Perf Sonar, and so what we do here, actually, we contribute with topology information from our national network. We're actually using NOV for that purpose, and we have traffic statistics that we export to this Perf Sonar effort. So one of the tools coming out of this that we really like is this, which ESNet has made, is the trace route visualizer, which gives you can cut and paste the trace route into the web form, and you can get traces, or you can get traffic statistics on every hop on the trace route taken from the underlying database. Okay, so finally we participate in the Lobster project, and here also the measuring beacons that we're placing. Actually, we plan to place beacons on all campuses, so we will have a total of 40 as we go along, or maybe more, as we go along in this program. And in addition to doing active monitoring, the measuring beacons also have passive monitoring cards with special hardware used in the Lobster project, MAPI software. So, and there's a lot of exciting stuff going on there, and I'm not going to go into detail here, but this will also be very useful for the Norwegian community. So, in summary, GigaCampus is a lot of things. We focus now currently on 7 areas of focus, 7 areas. New things may come into the program as we go along. And we have on top of the building, so to speak, we have our engineering task force, all the working groups, gathering all the best people, having them discuss and produce best practice documents. We do joint purchasing and call for tender, and we are out in the field and helping the various campuses with implementing new solutions in their campus networks. So there is an URL on the bottom. It's mostly in Norwegian, I'm afraid, but there is in English. You can click on English, and we have some, at least some overall information on the program at the website. You could also send an email to me or to this email address, or you can ask questions now if you have any. Thank you.
I'd like to thank Vidar very much. I'm afraid we're out of time in terms of the presentation, but you have the email address there, and also on the website you have Vidar's email address. So, and I know he'll be around for the rest of the morning at least, so if you can catch him. So thanks very much, Vidar. Our next speaker takes the network back right onto the campus, and it's Herman Moons from the University of Leuven, and he's involved in connecting the students, the real users of the network, to the and managing the real problem of the students. Oh, sorry, I get up the presentation.
Okay. Well, I'm very glad that Vidar's talk came just before mine, because he is looking at the whole, from an end-run perspective to the campuses. And here I zoom in on the campus itself, and you will see that there's a whole different set of problems that we are looking at that level. So this talk focuses, in fact, on how do you manage a campus network, a student campus network. So we don't look at the researchers in their laboratories, which have nice connectivity to the backbone and so on, but really to the students in their dormitories and in their rooms across town. And there you have different problems, really different problems. So the project I'm working at in my university, that's the University of Leuven in Belgium. We call the project COTNET, because COT is the name we give to a student room. It's a Dutch term. And our goal is, in fact, to provide our students with, let's say, high-speed and low-cost connectivity. Now, these things are often not going along together very well. But we try to get there. That's our goal. Give them high-speed, give them low-cost connection to the Internet and to the campus network. So the idea is that they get this access in their student room, so in their natural working habitat. So if they don't have to go to a PC class or a PC room or something like that, they can do it, get out of bed, get to their desk, and start working or playing. So this is what we want. They have to have comfortable Internet access. That's a requirement, we think. And we have noticed, we are already 10th year of the COTNET project, that this has been an enabler for e-university. So e-learning has become possible because every student has computer Internet access to the Internet in his room. At least we are getting there. So here's some historical data. So we started around 1995 with a couple of hundred students connected in a pilot project. And from the graph, you notice that, well, it's been going up in the early 2000s, and now it's flattening out. And the fact that it's flattening out is not because no more students are interested. It's flattening out because all students are connected. So we have about 25,000 students in the university, and you see that the graph stops around there, so we have covered pretty much everything. Now this is good. So every student has this COTNET connection, and this means that COTNET now can be viewed by teachers and so on as a, let's say, universal infrastructure. They know that every student has it, so they can do things on the e-learning platform without worrying whether a student has access to it. So every student has access, it's no problem. And been a rather successful project. And I know we have been talking in the past couple of days about gigabits and 10 gigabits and so on, but real life on campus is a little bit lower. So what we have at the university is a 400 megabit per second pipe for commercial traffic to our NRAN. So we have a gigabit pipe, but commercial traffic is only 400 megabits. And our students use about 300 megabits per second on a daily basis of that pipe. So 3/4 of the traffic is student traffic. From these 25,000 students, we note that about 20,000 connect every day to the network. So it's really, really successful. Concerning infrastructure, we connect them in a number of ways. We use different technologies, and these technologies will, new technologies, let's say, will be added when they become available. So we have our own buildings. That's the one in the middle, the student dormitories, owned by the university. That's very easy. We have single mode fiber to the building. We put fast Ethernet switches in place, and that's easy. That's the easy stuff. And of course, we have also the wireless hotspots, about 100 of them at the moment, where we just connect in libraries, auditoria, public places, and so on. So the students can, with their wireless laptop, get access there. But the majority of students, they are living in private rooms across town. And there we have an agreement with the cable operators in the Leuven area. And there's a commercial operator. So but we made agreements, and they ship their traffic from the cable network directly to the university network. So the internet access and the internet access is directly to us. And we provide the students then internet access. This was important because it could drop the prices. But the fact that there is a commercial provider in the loop gives us some problems. I'll talk about that in a little moment. So our goal there is also low cost. So the cost is there. For, let's say, 16 users on a shared cable modem, they pay around 300 euros a year, which is not very much. It's relatively cheap. Now, our largest problem now is how do you manage this stuff? We have 25,000 students, and they are sitting in their private rooms with their computers. And we have no control whatsoever over these computers. So it's out of our hands. They are sitting there somewhere out there in the city doing stuff on our network because they are connected to our network, and we have to be able to get a little bit of control over it. So it's a bit of a conflict. It's a Jekyll and Hyde approach. So on the one hand, we have to be nice. We have to support them and make sure that they can do their study, they can do their research, and that there is room for recreational use. And they have to be able to do some playing on the network. That's all right, but on the other hand, you also have to be firm, because there are always students who, let's say, misuse the network, and they can cause lots of problems for other students who are behaving in a correct manner. So these network abuses, we have to be able to avoid them, and this means that you have to implement measures to actively counter abuses. So you have to detect them and react to them, and preferably in an automated way, and so that you don't have to do this manually. Because if you have to do manual firefighting, you get exhausted pretty quickly. So what we tried to do on our network is to reach a balance between, let's say, enhancing usability for the user and maintaining control. That was, in fact, our main goal. So we learned some lessons, and some of these lessons are, I guess, a bit controversial. One of the lessons we learned is that not is good for you. I mean, probably lots of you will not agree, but we noticed in our network that if you give students public IPs, you invite network abuse. So they start to publish all kinds of stuff to the internet, and then you have to adopt your firewalls, and they work around it, and so on. And what we knew, and also you have seen that lots of students are complete idiots with regard to IT technology. I mean, they are great in arts and great in economics and so on, but concerning IT infrastructure, they don't know anything about it. So they have very vulnerable PCs. I mean, often they arrive at university, they don't even have antivirus on it. So if you give them public IPs, they are really vulnerable. So we decided to be bad, and we gave them private address space, and we do network address translation on the internet boundary, which effectively blocks illegal servers within the university. Setting up an MP3 server or an MPEG server with illegal content it's not that easy anymore. And more importantly, for the, let's say, the unknowledgeable students, it serves as an implicit firewall because it's not a public IP address. Of course, it's not really nice for the students, so we put some other things in place. And we have at the university, let's say, a number of student computer clubs, real enthusiastic people who want to do stuff. And we give them public subnets. And they can put servers in place, and they can do all kinds of stuff, and services to the student community and so on. But the important point there is that these public subnets are under control. They are on controlled locations. We give them the rooms to put their servers and so on. And we put a firewall between them and the rest of the student network, so we can monitor the traffic. And we have control over it. We work also very closely together with these student computer clubs. So if there is need for, let's say, internet accessible servers, we refer them to the student computer club, and they can buy, or for a little amount of money, can buy some disk space there, or can put their server there, and so on. So this works really nice. Also, these private IPs, of course, we route them normally within our intranet. And because the student room is connected to the intranet, this means that students, for, let's say, projects and so on, they can put servers up, and they can communicate with each other, because inside the intranet, everything works just fine. It's an intranet, and we route everything normally. So there's no problem there that we block some traffic. And our lesson here is that this NOT stuff has really been helping us, because at the beginning of the COTNET project, we didn't use NOT. We gave public IP addresses, and we had lots of problems with, let's say, the intellectual property guys out there who came with complaints to us about students accidentally distributing copyrighted material. And with this not in place, it's not that much of an issue anymore. Another important lesson is you have to know your enemy. Let's say the normal user is not a problem, but it's these 5% of the bad guys among the student population. You have to be able to know them, where they are. So authentication is very important. And again, we had a problem that all these guys have their own computers. It's lots of different operating systems, old stuff, new stuff. There's no line across what they have concerning equipment. So you have to be able to implement an identification service which doesn't imply any client software on their PC. So the only restriction we impose is you have to have a browser with SSL. That's it. So every computer has that. So it's the same thing that we use here to get on the network. You redirect them to a web page where they have to log in, and you collect these credentials. So authentication has really helped us to follow up on complaints. So if something goes wrong, we are able to look who is the user, which is his IP address, or which cable modem is he connected, so we know where he's physically in town, and we can follow up on complaints. And our help desk really loves it, because the help desk, we can now write automated tools for the help desk. If a user calls, he just has to give his name, and we can look up, oh, you're on that machine, that's your IP address, that's the connectivity you do, oh, you're on that cable modem, everything, the signals is fine, and so on. You can do lots of checks. So this was implemented with a network login mechanism, where we redirect users to a web page when they use their browser. So the real important thing there is that the network is not anonymous. And we tell students that it is not anonymous. And just a student just knowing that we know that he's there, it reduces misbehavior. So what they get is this page where we ask for the user ID and password, and they have to select the institution, because we offer COTNET not only for the university but also for some schools in the Leuven area. The nice thing about this login page is also if you get the result page, we can give some extra information to the users. So we have the possibility to have a message of the day, Unfortunately, here it's in Dutch, so we probably won't be able to read it. But students now, we can disseminate information to them in this way. So if something important is going on, or there's planned interventions on the network and so on, we can announce it. And they are able to know what's going on. Concerning the infrastructure, it's very simple. User is at his computer. When he starts using the net, probably when he starts using his browser, we intercept the request, redirect it to a net login server, and then do the authentication. And the authentication is verified against the backend LDAP server of the home organization. And then when the, let's say, user ID and password are okay, we also do some authority checks, and some authorization checks. For instance, is the user on a blacklist somewhere? We talk about blacklists later on. Did he get his IP address from a DHCP server of the university and so on? So there's a number of checks that we can do. And once everything is checks out fine, we reprogram the router and allow the machine of the student access to the network. And then from that moment on, he's connected. Another thing that we learned is that students, they eat bandwidth. I mean, you give them a gig and they will probably be able to use it. But we also noticed, when we took a little bit closer look at the traffic they are generating, that more than 50% of their traffic is non-educational. So let's say non-educational, that means really non-educational. And if you look at the non-educational traffic, what we saw is that over 90% of that non-educational traffic is illegal traffic. I mean, that is video, not their own videos, but films, recent films, music, lots of that stuff that's copyrighted material. And of course, as a university, we cannot tolerate that. I mean, that's not our, if we know about it, we have to do something about it. So what we did there is implemented some measures to get this illegal traffic under control. And the first thing we did was implement peer-to-peer protocol filters. So we did some string filtering on all the packet streams, and this reduced immediately our internet capacity to 50% of what we were using before. Now, of course, if you do string filters, you filter out some protocols, and the students start working around it. And very quickly, they started working around it and find new ways to get their illegal content. And then we needed to implement some other things. And one of the things we had to implement was upstream quota. Upstream quota and very low quota, it's 200 megabytes a day, which was in fact just meant to prevent intranet file sharing. I mean, if you have 200 megabytes upstream, you cannot put an MP3 server in the air and start serving data. Now, that worked very well. The only thing we noticed then is that they stopped setting up their own servers and they started downloading everything from the internet again, bypassing the peer-to-peer filters. So the next step we did was implement downstream quota. In the first round, we implemented downstream quota, let's say, only by looking at the top 10 of the users and then taking some measures against them. But we also had some problems with, let's say, our commercial ISP, so the cable operator. And the cable operator had some corporate problems. I mean, the problems he had was that we have a COTNET subscription, which is very cheap, but which had specs which are better than the commercial offerings that they had. And they couldn't, to the corporate headquarters, they couldn't say, okay, this is something normal. So they had to do something, and they asked us to implement volume quota in a downstream direction. So we did then some measurements on the traffic, and we noticed that 4 gigabytes a month was okay for 95% of the students. That's commercial traffic. So let's say we implemented that, and okay, the students didn't complain very much because we communicated very carefully to them in student working groups and so on. So that went very well. But to soften the blow, we implemented some exceptions to the rule. So one is that certain students, for their research purposes, they need more bandwidth. So that's okay for us if their professor approves it. So then we give them an exception, they can use more bandwidth. Another thing is that traffic to the e-learning environment is free. I mean, that's learning, that's educational traffic. There's no limits on that. So limits are only for commercial traffic. And the last thing we learned is that these users at home are in a non-controlled environment, and lots of these users are computer illiterate. They don't know anything about computers. So they install all kinds of software. So their friends say, oh, this is nice, install it. Well, they install it. You also notice that they click on everything they see. I mean, you pop up some box with an OK button and they click it. So this is real bad because, you know, lots of viruses and so on, they distribute via email. There's some things that you click somewhere and the virus gets installed and so on. And these users, they have no idea what they are doing. So these viruses arrive on their PCs very quickly. And this was not a problem. The problem also is that in the university, every year new students arrive. So you have to do constant firefighting at the beginning of the academic year. And we were getting tired of this firefighting. So we tried to find some ways to automate the detection of these viruses on the .NET user PCs. Now, these viruses, you have to contain them because they new viruses, they tend to spread very rapidly. And they can cause real damage on the network if there is a virus wave coming on. So we identified some requirements. So the first thing we needed to do was to say, detect and contain viruses as soon as possible. And also very important, educate your end user. So it's not enough to clean their PCs, either automatically or not, but the user itself must become aware that the internet is not something where you click on everything. And the only way that users learn is the hard way. So we implemented some measures to make them learn the hard way. So if we look at the problem of virus detection a little bit in more detail, we see that viruses typically distribute in two ways. One is that they start scanning the network, port scans, host scans, and so on. And this kind of information typically shows up in NetFlow logs. So you've heard lots of talks about NetFlow, and it's really a useful tool. I mean, you can get lots of information on that if you do some data mining. So we use NetFlow to gather information, and we detect host scans and port scans in these data. So we know when a virus is starting on a PC because you notice a different shift in the number of port scans and host scans that the PC does from the normal behavior. The other thing the viruses do is they have built-in email engines, and they start emailing themselves to everybody in your address book. Now at the university, of course, we have a central antivirus cluster in place, which must be used both for incoming and outgoing email traffic. So when traffic goes out, email traffic from an infected PC, it will be detected by the virus cluster, and we can do some coupling back to our infrastructure to detect the PC that has the virus. So the architecture is as follows. You have at the left side the user analyst infected PC, and the virus spreads by doing host scans or port scans or emails. Host and port scans, they show up in the NetFlow analysis scripts. Emails show up in the antivirus cluster. And then we do the back coupling there to the blacklist server. So we gather this information on the blacklist server. And the blacklist server, what he does is he gets an IP address. When this IP address is infected, we couple that back to our netlogin server, where we know the coupling between user and machine. So we ask, who is this IP address? And we get back, okay, this is this user who is using that PC. And then what we do immediately is we log out the user. So we send a message back to the login server, and the login server reprograms the router, puts an access list in place that blocks the PC. And this is done, let's say, in near real time. We do this every 15 minutes. So let's say if the PC gets infected, 15 minutes later, he's kicked off the network. Now, this blacklist data is then kept in a blacklist database, which is used later on for the login system also, as I will come to in a moment. So blacklist database, I'll skip it here. It's just an SQL database where we keep details about the kind of incident. Now, what happens now when the user is kicked off the network? Well, typically what he does is he logs on again. He starts logging on again. What you do then is when he logs in, the login attempt will fail. It will fail because the end user is kicked off the network and has a virus and he has to do something about it. Now, the problem we notice is if you are nice to your users and you inform them that they have a virus and they have to do something about it, they never listen. I mean, if you tell them something, they forget about it. As long as theirs can work, there's no problem for them. So we give them a login failed message, and we say, okay, your PC has been infected, and these are the steps you have to follow to solve that problem. So we give them really detailed instructions about how to install an antivirus from the university. They can get it for free, what tests they can run to detect what kind of files they have and how they can remove them and so on, and how they should behave in the future. Now, of course, knowing your users, when you get a page like this, they say, okay, scroll, 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 and they scroll down to the bottom, and there they see a button, please reactivate my account. Okay, they say, oh, all this stuff is too much to read. Click. And that's the typical behavior of a user. So the user reactivates his account, and he can log in again. Of course, after 15 minutes, he's kicked off the network again, because he hasn't solved this problem. And of course, we are nasty guys, and what we do is, once they have reactivated their account, they can only do this once a day. So typically what they do is they click, reactivate their account, 15 minutes later, kicked off the network again, and then they have the whole evening to fix their PC. And we notice that this really helps. I mean, you force them to do something about it, and they become aware. And this is, has been really, really effective. Now, our conclusions are that the COTNET project for us, giving the student access in his room to the network, has really been a great help for the e-learning environment at the university. And now COTNET is considered, in fact, basic infrastructure. If you rent a room in Leuven for a student room, COTNET is typically part of the room. I mean, the landlord, he will probably get a subscription with the cable operator to get COTNET in his room, so that he can offer rooms with internet connections to the university network. What we also learned is that control is essential. I mean, you have always find the balance between enhancing the network for the user, making it useful for him, and restricting the user when they do nasty things. So the mechanisms we put in place, they are unobtrusive to the normal user. A normal user doesn't see anything from all these stuff that we put in place. They don't notice anything, they just work. It's only when they start behaving badly that these mechanisms kick into place. So, and these are also automated. I mean, as network administrators, we don't have to do anything about it. It just regulates itself. Of course, this is not something you can buy on the market, so you have to do some in-house software development. Well, we typically implement some things ourselves for login, bandwidth control, the automated antivirus detection, and so on. Lots of this is done with Perl scripts. Also, one of the things we learned is that change is the norm in university networks. I mean, you have a continuously changing student population, and you have new applications arriving, bandwidths increasing, and so on. So the mechanisms we have put into place now, they work just fine for the moment. In 2 years' time, probably we'll have a whole range of new mechanisms to try to control the network. So let's say it's a continuous quest for finding this balance between making the network usable and keeping it under control. Thank you.
Thanks very much, Herman. We have time for a question.
The fact that you're trying to limit the student behavior on the P2P protocols with the stateful firewalls, I think makes them push them to use well-known ports, like port 80 or port DNS. So, do you have layer 7 stateful mechanisms for those protocols?
Okay, yeah. No, what you say is right. But these peer-to-peer string filters, they worked at the beginning. But we noticed that students started working around it. And we found tunneling over ICMP, tunneling over port 80. But we could do some things with string filters, because then you look really at patterns in the packets themselves. And that worked quite nice. But latest generation of students, they start encrypting their traffic. And then you can't detect it anymore. But the real thing that helps there now is the volume limits. I mean, that's that they can't work around that.
Yes. I can prove to you that now, I mean, if I put a volume filter to you and be as an outsider, I can make you pass over the volume. Because imagine that you are a student and I send you DNS queries, okay, as much higher as I want. and
Yeah,
port
okay.
53. So what I can do for you is to make you lose all your annual or monthly or daily volume. What do you do
Yeah.
about that?
No, we try to detect, well, we have lots of check scripts in the background that try to detect malicious patterns. It's not fail-safe. I mean,
No, I mean, how
not
do you respond
100%.
to false negatives? That the guy is not...
Yeah, then we have to help us. They start contacting students, and we try to get some information from that.
You-
But if the guys who are doing this bad stuff, I mean, what we try to do is we try to recruit them. I mean, they're really good networkers usually.
But do you believe that the operating expenditures for that is higher than getting the bandwidth in place? Because nowadays, I mean, 1 gigabit per
No,
second...
okay, yeah, but getting bandwidth in place is not always possible. You notice that we work with a commercial operator.
Yeah.
To get the bandwidth, with commercial operators, if you could get fiber to the home, no problem there. But with a commercial operator, it's not possible.
Okay, thanks very much for that. I'm afraid, once again, we're out of time, so thanks, Herman. Our next speaker is Ligia Maria Ribeiro, who comes from Porto, in Portugal, and who has a list of presidencies and vice presidencies in our university, and also is, and probably the subject of our talk, is the president of the UNIS organization. And this takes the network from being the boundary between the national network. Now we've been to the campus network and the students, and now we're coming down to applications type work. So, Ligia.
Thank you, Michael. As Mike said, I'm president at this moment of the UNIS organization for the last 2 years. On behalf of UNIS, I would like to begin by thanking the TNC Program Committee and Terena for inviting us to be here at this prestigious event and to have the opportunity to talk with you about the user perspective and in particular the management perspective concerning ICT in higher education institutions nowadays. So I will begin by explaining you briefly what UNIS is, and then I will point out some challenges European higher education is facing nowadays. And in relation to that, I will address new opportunities and new roles for IT services. IT services are becoming more strategic. And also in relation to that, I will address some opportunities for cooperation between UNIS and Terena. So what is UNIS? UNIS is the European University Information System Association. This association was founded in 1993, aiming to bring together information systems leaders, IT leaders, heads of management, and also ICT major suppliers to discuss the main concerns in relation to ICT in higher education and research. So at this moment, UNIS has more than 90 members all over Europe, and some of these members include national associations. And I remember, for instance, UCISA from the UK, ZKI from German, XIR from France, SURF from the Netherlands, among others. And also some of our members are corporate members, like, for instance, Sun, Oracle, Microsoft, Blackboard, SAP, etc. So what are the UNIS objectives? The main objectives are, first of all, to encourage communication, collaboration and cooperation between those responsible for information systems in higher education and research. And we also want to act as a go-between higher education and major suppliers in the field, as I said before. And third objective is to link with organizations at the national and the European levels, which are setting strategic agenda concerning information systems in higher ed. So speaking about these linked organizations, Well, as I said before, we have national organizations that are full members of UNIS, and we have presently agreements, formal agreements with the Turena and also the Gartner Research. And we are finishing also agreements with the CODIT, the Council of Australian University Directors of IT, and also ECMA, the European Knowledge Media Association. And we worked for a long time with other associations, and we are at this moment establishing closer links and more formal links with EduCause, with the European University Association, and also with UMaine, the heads of management and administration network in Europe. So what does UNIS do? Well, of course, I'm not going to speak of all the activities of UNIS. I just want to highlight a few of them. First of all, the surveys. There are several surveys available at the UNIS site, and I call your attention for the survey our previous president, Crystal Sarlin from Finland, shared about costs and structure of scientific networking in European countries. And also recently the survey shared by Jan Stinson from the University of Liverpool and UCISA concerning top concerns survey at higher education. This was a UCISA survey that was extended to UNIS members and was presented at last conference in Manchester. UNIS also organizes several special events, and I want to emphasize in particular the Rector's Seminar Series. The last one was in Paris, March, and it was about the impact of the Bologna process on IT in universities. We were able to join together rectors, vice-chancellors, presidents, and major suppliers, as I said before, in ICT, to discuss the issues concerning the rapid growth of IT in our educations nowadays. And, of course, the main events UNIS organizes are the annual conferences. And next conference in June in Tartu will be the 12th of a series that started in '95 in Düsseldorf. And on these conferences, of course, several topics are addressed, but I can say that in general, the main areas covered are ICT infrastructures and services, ICT for teaching and learning, and also digital university administration. So I hope that next June you can be out of office and join us in Tartu. Several topics that are covered by this conference are here listed. Some of them are, I know, of the interest of Turena. And I also know at this point that several Turena members already registered and are going to present Turena activities and projects. And this leaves me to speak about the UNIS and the Turena cooperation. I'm a strong believer of the advantage of this cooperation for higher education and research in Europe, because Turena and the UNIS have complementary aims and objectives, and we all want to promote the existence of high-quality infrastructures in higher education, explore new directions in IT also for higher ed, and to contribute to innovation and excellence in IT. So I will speak about these cooperation opportunities in a few moments, but I want to frame these opportunities in relation with some challenges that higher education in Europe is facing. And I select three major challenges. Funding, of course, as ever, but I will say it's more severe now. Global competition, and also the challenges that result from the implementation of the Bologna process that is in place presently in Europe. So, beginning with the funding, we all know that universities worldwide are pressed to deliver more with less money. And this has to be, of course, with better governance, with more efficient management of resources. And we know, that work with technology, know that technology has a very important role here, because it impacts both the administrative aspect and also the pedagogical aspect. But it is important to create this awareness at the management level. So local IT services are becoming more strategic, but this must be recognized by the management of the institutions. And what we can call the CIOs of higher education should participate in a regular basis in the administrative management meetings. Global competition. Well, as a consequence of global competitions, higher education institutions must increase their attractiveness and show their excellence and efficiency both in research and education. And they must show this. And of course, concerning this aspect, I think target marketing is an issue here. And many universities are doing this, in particular in UK and Ireland. But we must increase this target marketing in other regions in Europe, although this can be not very well accepted because it's not in alignment with the culture and the tradition in high education. But this is really an issue that we must think about. And of course, portals are very helpful in this respect. And we must design portals in order they respond effectively to the needs of our clients, of our students, of our academic. And Bologna, of course. Bologna is about establishing the European higher education area. And the main idea is to enhance attractiveness and competitiveness in higher education in Europe. So the main issues here are flexible studies for students and also student mobility. Student mobility must increase. And of course, this has consequences in pedagogical and curricular contents. And we need to rethink quality assurance. And of course, there are already in place some instruments for the adoption of a system of readable and comparable degrees. And these instruments are, as you know, the European Credit Transfer and Accumulation System. This is based on the global student effort, and it's normalized by time. You have, besides ECTS, a relative system for classification. This is a percentile-based system, classifications from A through F, and a diploma supplement. And this diploma supplement somehow compensates for the relative classification system, as it describes what the students have achieved. So, to implement this cooperation in an effective way, we need standards. We need to increase the way how this information is transferred between institutions. Nowadays, for instance, Erasmus programs are dealt mainly in paper form. So we need to increase mobility, but we need at the same time to have frameworks for effectively transferring, for instance, student information, also staff information, academic records, etc. So IT services are becoming more strategic, and you all know what strategic is about. But what I think is lacking here is to relate the going ahead of IT services with the going ahead of the institution itself. So it is necessary that we can speak the same languages as managers. Managers understand the importance of ICT to respond to their concerns, and the several activities at the university know exactly what the IT services is doing, and in what respect what we are doing is responding to these concerns. So, as I said before, I believe that CIOs must be a key contributor to formulating the strategic goals in higher education. So, there are, of course, several cooperating opportunities for Terena and UNIS. And I just list here a few in relation with the development of common infrastructure projects, and also in the sharing experiences, and essentially in disseminating best practices. And of course, standards. We need to have standardized data models to increase this interoperability that is necessary nowadays in our higher education. So let's see, for instance, what we can do in networking. As our previous speaker referred, the campus level is an issue here in terms of bottleneck. And as he said also, it is very important that in an annual basis, these networks, these campus networks are conveniently, adequately upgraded. So we need that management just provides the resources necessary to guarantee these upgrades. And also that there is the adequate investment in professional training. So we can develop strategies to create this awareness at the management level in order money can be available for upgrading these networks. And I strongly believe that the NRENs in the national, in the international aspect are essential, because commercial solutions cannot respond effectively, in my opinion, to the needs of research and education. But we must look at sustainability of these models. And also the previous speakers spoke about nomadism and the necessity that student mobility will increase. So we need to provide wider access to resources. And, for instance, I call your attention for EdROM. Well, EdROM is a first step, I would say, a very important first step, but you must go forward. Because, for instance, you must provide to the students the same services in different institutions, as students are now going to have their programs in different institutions, and they expect to have the same services. So you need to decide about a common set of services in EdROM. And you must go further, because, for instance, students that are in one institution needs to access, for instance, the library catalog. And they want to do this in the several institutions where they are working for their programs. And another example is distributed printing. For instance, for student residents, they must have facilities for printing. So, for instance, in the first day, Martin Beck spoke about connecting agreement services in terms of medical aspects for teaching and also for working in health areas. Is that also necessary for education in a more wider sense? Or is, for instance, IPv6 will solve most of these problems? So we must give answers to higher education. And in terms of IT services, of course, we need federations. And we must adopt federations in a wider manner in higher education in Europe. So I think there are needs for technical and operating guidelines to install proven and interoperable solutions in IHED. Of course, one aspect that is also very important is to increase these online transaction services. And for that, digital certificates are, of course, necessary. And this is not only for servers, but also for the users. So why not to extend the hierarchy of certification authorities that we already have in higher education for grids and applying that also in a more general way. But of course, if we increase this online interactive transaction service, we must also do a significant role in looking to the modeling of our process in higher education. Horizontal to all this, as other speakers already said, are concerns about privacy, security, and confidentiality. At the local part, I would like to emphasize the necessity of having integrated help desks, and this help desk issue was also referred before, and to maintain permanent services. It is not sufficient to say that the servers are connected, are running, because sometimes they broke, and we must have conditions for staff to go there and solve these solutions in out-of-hour period. And not many universities have this service running at this point. So in terms of information systems and applications, well, as I said before, we need to have information systems responding to some new features. For instance, to have this interoperable curricula, as students will have access to different parts of their study done in different universities. And we need also to exchange electronically academic records and diploma supplement. And also, of course, curricula contents for the staff, for the faculty. There are some systems already up and running, like Europass and like LATS. But are we going to adopt these systems as de facto standard in higher education? Are they interoperable? How do we exchange this information effectively? And of course, we need to disseminate news, and this is, I think, solved if higher education could have ATOM and RSS use all over. So, and what about higher education assessment? In this respect, I think the directions should be in terms of normalization of data warehouses, because you need to have common definition for key indicators of performance. If you have not these common definitions, how are you going to compare the institution performance and do assessment? So you need to look at this and have these common definitions for performance key indications in order to apply, for instance, balanced scorecard systems. So, and you must, of course, follow the user. So you must have, for instance, techniques of click streaming to see if what you are offering responds to what the users really need. So to finish with, I think there are really several cooperation opportunities for Terena and for UNIS. You must, we must identify the priority areas and define models for cooperation. And we must increase awareness between Terena and UNIS members and all in the European higher education area to go towards this unified digital campus vision that I see as a campus that is supported in its main activities with IT in a secure, seamless, and transparent way. Thank you very much.
Thank you very much, Lydia. It sort of brings the network up to a layer 8. I don't know whether layer 8 has been defined, but this brings the human into it. We have time for a couple of questions. If anyone has any questions, I know again, these will be around like Herman and Vidar.
Okay.
All right. Can I just remind? Oh, sorry, Mike.
Yes.
Okay. I wonder whether talk of mobility. You know, the automatic thing is the Erasmus program and student mobility and so on. Is that the only outcome of the Bologna process when it comes to integrating students across faculties in Europe? I mean, there are other kinds of mobility, and there's virtual mobility, as it were. I mean, is that on the agenda as well? I mean, what about the fact that you know, students nowadays have much more access to resources around the globe than they did when Erasmus first started, and the idea is now that faculty can also be moved virtually.
Yes, you are absolutely right. We need this more wider interpretation of mobility, and I think that there are many issues that must be solved at the university level and faculty level in order to provide this virtual mobility and access, open access, for instance, for teaching and learning resources. But this obliges that we look also to data privacy, and we look at copyright issues in order, for instance, to offer the students seamless access to the learning and teaching resources. I don't know if that was your question. Okay.
All right. I'd just like to thank our three speakers again this morning. I think it was an excellent session and tied together up this. Thank you.